Assalamu alaikum wa rahmatullahi wa barakatuh. This is Nazar Ibrahim, mathematics teacher, and today we are discussing 0580 mathematics course IGCSE, and this is from teaching by SM channel. And as we all listen to this sentence in all videos, that overall revenue which will be generated from these videos for the first 6 months will be donated to Palestine. So I would request all the viewers to kindly support our cause. Jazakallah khairan. Okay, the topic to be discussed today is vectors, as you all can see over there. So starting from the first question, the diagram shows a parallelogram OCEG. O is the origin, which is over here. OA is equals to A, OB is equals to B. BHF and AHD are straight lines parallel to the sides of the parallelogram BHF and AHD. Okay, OG is equals to 3OA. OG is equals to 3OA. It means that if OA is equals to A, then OG is equals to 3. OA is A, so 3A. So OG in total is equals to 3A. So definitely AG is basically part of OG, right? And OA is equals to A, OG is equals to 3A. So 3A minus A, AG is equals to 2A. Similarly, OC is equals to 2OB. So OB is equals to B. OC is equals to 2OB. So OB is equals to B. So OC is equals to 2B. Clear? So in total, OC is equals to B. Okay, now BC is part of OB, right? So OC minus OB will give me BC, which is 2B minus B. BC equals to B. Clear? Write the vector HE in terms of A and B. So the vector HE starting from H and ending at E. This is the vector which we have to find out. Vector is denoted by usually with two letters. HE means started from H ending at E, right? And to calculate this vector, I have to use the addition rule of vectors. And what it says that starting from the tail of the first vector, like for example, if I want to calculate HE, I will see the tail H. From H, how many vectors are there? So one is HD and the other one is DE. If I add HD plus DE, I will get HE, right? So HE is equals to HD plus DE. Now what HD is, since HD is parallel to BC and equal definitely, so HD is equals to B. D is parallel to HF, HF is parallel to AG and equal, so AG is equals to HF 2A, similarly DE 2A. So HD is B and DE is 2A, so B plus 2A is the answer of HE. Clear? Okay. The other root of HE calculation is from starting from the tail H, HF plus FE. If I'll sum these two up, I will get the same answer, B plus 2A. Clear? Let's move forward. Okay. Complete this statement. A plus 2B is the position vector of point. A plus 2B is the position vector of point. Okay, now what A plus 2B is? This is A, so A plus 2B. This AOC is 2B and AD is also 2B, right? Because AH is B parallel to OB and HD is also B parallel to BC. So summing AH plus HD, which is in total AD, is equals to 2B. So A plus 2B, OA plus AD will give me A plus 2B, right? And it's a position vector. Position vector is a vector starting from usually from O, origin. So it is a position vector of D, right? It means that starting from O ending at D, OD basically. So basically it's a position vector of point D, which can be written as OD. Clear? Position vector is a vector starting from O, right? Let's move forward. When two vectors, write down two vectors that can be written as 3a minus b. Now first, what 3a and what minus b? Minus b, it's just the change of direction of b. If this is equals to um, OB is equals to b, since we know that OB is equals to b, so BO will be equals to minus b. Clear? So just the change of direction when the negative sign is there. So 3a first, let's see what 3a is. 3a is C, 3a is OG, and 3a is BF. Now 3a minus b, right? Minus b. FE is equals to b because FE is parallel to BC and BC was b. So FE is also equals to b. What minus b will be? EF. FE is equals to b, EF is equals to minus b, right? So EF is equals to minus b. So starting from 3a ending at minus b, CF is the first vector which is equals to 3a minus b. Is it clear? Okay, 3a minus b. Similarly, again BF is equals to 3a and FG is equals to minus b. GF is equals to b parallel to OB, so FG is equals to will be equal to minus b. So starting from B ending at G is the second vector BG, which is equal to 3a minus b. So first is CF and the other one is BG. Clear? Okay, moving forward. Question number 2. The vector GH is given to us in this form 6 minus 4. This is in x direction and this is in y direction. Find 5GH, 5 into GH. So simply multiply 5 with the vector GH, both the components. 5 6 is 30 and 5 into minus 4, 5 into minus 4, minus 20. Second part, find HG. We are given GH, HG is just the reverse direction, so change the signs. 6 will be equal to minus 6 and minus 4 will equal to 4. Okay, let's move to part B. Part B is see 6 plus 2, 8. We can see it's same. 7 plus y is equals to 3. Find the value of y. Simply 7 plus y is equals to 3. 7 will go over there. So 3 minus 7 is equals to minus 4. Clear? Okay, let's move further. Question number 3. In question number 3, we have three sides, basically a triangle. Vector P, OP is equals to P, OQ is equals to Q. So these are two vectors, position vectors of Q and P are given to us as OP and OQ equal to P and Q. And we are given the ratio of PZ and ZQ, right? So we have to work out in terms of P and Q, the position vector of Z. So position vector of Z means starting from O ending at Z. This is the position vector of Z, right? Now, if I want to calculate this position vector, I need to sum up OP and PZ, right? So OZ is equals to OP plus PZ, right? Now I know what OP is, I want to find out PZ. But in order to find out PZ, I should first know that this whole PQ, right? So whole PQ is PQ, a vector if I want to calculate this, I just need to sum the last vector, sorry, OQ, is OQ minus OP. Subtract the first position vector from the second position vector. So OQ is equals to Q and OP is equals to P. So PQ is equals to Q minus P. Now first I want to know PZ, right? PZ. So PZ is equals to, using ratios, 5 is the ratio of PZ, total is 5 plus 2, 7, and PQ is Q minus P, right? Q minus P. So now OZ is equals to OP, which is equals to P, and PZ 5 upon 7 Q minus P. So taking LCM, this is 7P plus 5Q minus 5P, which is equals to 7P minus 5P is 2P plus 5Q upon 7, which is equals to 2 upon 7P plus 5 upon 7Q. Right? Clear? Okay, let's move further. Question number 4 is D is the point 2, minus 5. DE is a vector 7, 1. Find the coordinates of point E. So let me make it a little bit upwards. Okay. So D is a point, for suppose I'm making it over here, and E is over here, and O is over here. It's just a random figure just to explain what this means, right? Suppose this is O, D, and E. The D is the point 2, minus 5, simply, which I can write it like this as well, 2 minus 5. DE 7, 1, right? So DE is 7, 1. We can see this, we can say it as D, or we can also say it as OD, right? That's OD, and there's OE, right? So OD plus DE, according to this addition of vectors rule, is equals to OE, right? Now OD is equals to 2 comma 2 minus 5. DE is 7, 1 is equals to OE, which is basically the coordinates of E. So 7 plus 2 is 9, minus 5 plus 1 is minus 4. Clear? Okay. Part B is V vector is T12 and magnitude. This is the two walls which are surrounding the vector V. It is called magnitude. Magnitude of vector V is equals to 13. Now the formula for magnitude is, for any vector's magnitude is this formula. X is this part, the upper part, Y is the lower part. So the magnitude of V is equals to 13. It is given to us. X is equals to t square, plus Y is equal to 12 square, right? Now going forward, if I want to solve, I will have to take squares on both sides, so that square root finishes. So 13 square is 169. Square root finishes with a square. So t square plus 12 square is 144. Clear? Okay, now t square is 140, will go over there, is equals to 169 minus 144 is 25, right? Now if I want to calculate the value of t, what I need to do is taking again square root on both sides. So t is equals to plus minus 5. And if it has stated in the question, work out the value of t where t is negative. So negative of t is minus 5, not plus 5. Clear? Okay, let's move further. Question number 5 is, we are again having a triangle. We are again having two position vectors A and B, right? And AK ratio KB is given to us 2:1. Okay. Find the position vector of K. It means that the vector starting from O ending at K, which we are to find out. Okay. So OK is equals to OB plus BK, right? So OB is known to me. I have to find out BK. First, I will find out BA or AB. Since we need to find out BK, so find out BA. So BA is equals to OA, the second vector, minus the first one. So OA is equals to A, OB is equals to B, right? So BK is equals to, the ratio is 1 upon total is 3, A minus B, right? Is it clear? Okay, so OK is equals to OB is B, BK is 1 upon 3, A minus B. So it means that taking LCM 3b plus A minus B, which is equals to 2b plus A upon 3. So we can say it as 2 upon 3b plus 1 upon 3a, breaking out LCM. Clear? Okay, let's move forward. Question number 6. In question number 6, we have diagram. O is the origin. We are given OD, a position vector of D, position vector of C, and the vector DE, A minus 2B, right? Find CD in terms of A and B. Find CD. To find out CD, we should have two vectors which are known to us. Very simple. So CD is equals to OD minus OC, right? So what is OD? OD is 4A plus B, and OC is minus 2A plus 3B. Don't make this mistake. Use brackets so that the signs are changed. 4A minus minus plus plus 2A plus B minus plus minus 3B. So 4A plus 2A is 6A plus B minus 3B is minus 2B. Clear? Part B is DE is equals to A minus 2B. Find the position vector of E. Position vector of E means starting from O till E, right? OE, we need to find out OE. So OE is equals to simply OD plus DE. So what OD is 4A plus B, and what DE is A minus 2B, right? So 4A plus A is 5A plus B minus 2B is minus B. Clear? Okay, going forward. Question number 7, I guess, right? 6 is done. Question number 7. Question number 7, again a triangle, similar type of things. Vectors P and Q are given, position vectors, and ratio is given of the line QP. Find the position vector of T. So starting from O till T is the position vector which we have to find out. So OT is equals to OQ plus QT, right? OQ is given. I need to find out QT, and for that I need to find out first QP. So QP is equals to OP, the second vector first, the first vector last. OP is equals to P, OQ is equals to Q, right? There's QP. Now going forward, we have QT. So QT is equals to, what is the ratio? 1 upon, no, sorry, 2 upon 2 is the ratio of QT, and the total ratio is 3. Whole is P minus Q. Right? QT is equals to 2 upon 3 P minus Q. Now, using these values, so OT is equals to OQ is equals to Q plus QT is equals to 2 upon 3 P minus Q. This is 3Q plus 2P minus 2Q. So this is 3Q minus 2Q is Q plus 2P upon 3, which is equals to 1 upon 3Q plus 2 upon 3P. Right? 1 upon 3Q plus 2 upon 3P. Clear? Okay, moving forward to the question number 8. I hope everybody is understanding all the questions. Question number 8. In question number 8, we have a parallelogram OABC. We have OP and CA intersect at X, and CP and PB. CP and PB is ratio 2 ratio 1. Okay, O is equals to A, OC is equals to C. Find OP in terms of A and C. We need to find out OP in terms of A and C in its simplest form. Now to find out OP, what we need to know is OP is equals to OC plus CP, right? Again, we are not aware of CP, so to calculate CP, we need to first find out CB, and CB is parallel to OA, so OA is equals to A, so CB is equals to A as well. Now, what CP is? CP is a part of CB, so CP is equals to 2 its ratio upon 3 total A, right? So CP is equals to 2 upon 3A. Definitely this will be equals to 1 upon 3A, right? Now just putting the values. So OP is equals to OC is C, and CP is 2 upon 3A, right? Clear? So that is what the position vector of P is, OP. It's C plus 2 upon 3A. Clear? Okay. CX ratio XA is equals to 2 ratio 3. CX ratio XA is equals to 2 ratio 3. Find OX in terms of A and C. We need to find out OX, right? This vector. So to find out this, I need to find out OA, OC, which is given to me, and CX. So first CA calculation is necessary. So CA is equals to OA minus OC. So CA is equals to OA is A and OC is C, right? And accordingly, I need to find out first CX, right? So CX is equals to, the ratio of CX is 2, right? 2 upon total is 5, 2 plus 3, 5, and A minus C. So this is all about CX. We have found out CA, CX both. Now we need to do working for OX. So OX is equals to OC, which is equals to C, and CX, which is equals to 2 upon 5 A minus C. Right, so taking LCM, I'll get 5, we have 5C plus 2A minus 2C, right, which is equals to 5C minus 2C is 3C plus 2A upon 5. We can write it like this: 2 upon 5A plus 3 upon 5C. So OX is equals to 2 upon 5A plus 3 upon 5C. Clear? Now find the ratio of OX and XP. So OX is known to me, which I have just calculated. I need to calculate XP. So first I know that what OP is, right? I calculate over here. OP was C plus 2 upon 3A. And OP is basically the sum of OX plus XP, right? Let's first move a little bit below. And I think I should erase this one. I will not be needing this. So OP is equal to C plus 2 upon 3A, and OX is equals to 2 upon 5A plus 3 upon 5C. So I need to calculate XP because XP magnitude is necessary. So OP plus X, no, sorry, OP OX plus XP is equals to OP, right? So XP, which I need to calculate, is equals to OP minus OX, right? So putting the value of a little bit upwards, okay. Yes. So okay, so XP was equal to OP minus OX, right? OP was C plus 2 upon 3A, and OX is equals to 3 upon 5C minus 2 upon 5A, right? Now simplifying this, I am getting XP is equals to 2 upon 5C plus 4 upon 15A, right? That is what XP is, right? Now I've got XP, I have got OX. Okay, so using these two values for ratio, I'm using it over here. OX upon XP is equals to, OX was 2 upon 5A plus 3 upon 5C, and XP is 4 upon 15A plus 2 upon 5C, right? Okay, so in the numerator we are getting 1 upon 5 as common, so I'll get 2A plus 3C, and in the denominator I'm getting again 1 upon 5 common so that I can cancel it out. So this is 4 upon 3A plus 2C, right? So the 1 upon 5 cancels. Now I'll just compare the components of A and B. I'll get the same ratio definitely. So 2A ratio 4 upon 3A. So A gets cancelled. 3 to the 6. 3 go over there. 6A, 4A. A cancels. 3 to the 6. 2 3 the 6. And 2 to the 4. So 3 ratio 2. I can choose another way, that is C side. I mean 3 components are 3C ratio 2C means 3 ratio 2. So the ratio of OX ratio XP is 3 ratio 2. Clear? Okay, let's move forward to question number 9, I guess, right? Question number 9. In question number 9, OABC is a parallelogram and O is the origin, CK is equal to KB, and AL is equal to LB, right? Okay. M is the midpoint of KL. Okay. O is equals to P. OC is equals to Q. Okay. Find in terms of P and Q, KL. We need to find out KL, right? This part. KL, right? To find out KL, what we need to know is these vectors. We know OC, right? We need to find out CK, and we need to find out AL, right? So first, CB is the parallel side of OA. So in total, it is equals to P. and CK and is equals to 2 KB. CK is equals to 2 KB. It means that CK upon KB is equals to 2 upon 1. Right? KB goes over there, 2 upon 1. So the ratio of CK and KB is what we have got from here, from this information. CK ratio KB is equals to 2 ratio 1. Alright. So first, C, you know what CB is? CB is equals to P as it's parallel to OA and equal. So CK is equals to 2 upon 3P. So 2 upon 3P is CK, and definitely this will be 1 upon KB is 1 upon 3P. Right? Now to find out KL is equals to KB, that is this part, plus BL. Right? So to first we need to find out BL, right? So to find out BL, we should do working for BA. Since AB is equals to Q, right? So B is equals to minus Q. Okay, and since AL is equals to LB, it means L is the midpoint. So B A is equals to minus Q, BL is equals to minus 1 upon 2Q, right? Okay, so KB is 1 upon 3P, BL is 1 upon 2Q. That's all about KL. Very simple. Okay, now position vector of M, right? So starting from O, ending at M. Position vector of M, right? So OM, now starting from this tail OC, if I write it like this, OM is equals to OC plus CK plus KM, right? Now OC is known to me, CK is known to me, KM I need to calculate, right? So we just now calculated KL, and M is basically midpoint of KL, right? So KM is half of KL. What is KL? 1 upon 3P minus 1 upon 2Q. So half of this whole 1 upon 3P minus 1 upon 2Q, right? So this will be 1 upon 6P minus 1 upon 4Q is KM, right? Now adding all this up, putting in the values, OC is equals to Q, CK is equals to 2 upon 3P, and Km is equals to 1 upon 6P minus 1 upon 4Q. Right? Now let's simplify this all. Wait a minute, let me wind this up so that it becomes easier to understand. I am doing the working over here on top. So Q minus 1 upon 4Q and 2 upon 3P plus 1 upon 6P, right? Taking a separate LCM, this is 4, so 4Q minus Q. Okay, this will be the LCM will be LCM of 3 and 6 will be 6. So 3 to the 6, 2 to the 4P plus P. So this will come up to 4Q minus Q is 3 upon 4Q plus 5 upon 6P. That is the position vector of M, right? Clear? O M. Okay, moving forward. Question number 10. Okay, question number 10 again. There's a compounded shape. Okay, a compounded shape having a parallelogram and a triangle. The values AB, AD are given to us. Ratios of AB, B ratio, BM is given to us. and AD ratio DN is given to us. Okay, right? So first we should use the data and take out these values, right? So AB ratio BM is 1 is to 1, right? So if AB is Q, so definitely BM will also be equal to Q. Okay, that's very clear. Okay, then AD ratio DN is 3 ratio 2. AD ratio DN is 3 upon 2. So AD is equals to P, right, upon DN is equals to 3 upon 2. So dn is equals to 2 upon 3p. So dn is equals to 2 upon 3p, right? And vm is equals to q. Okay, this is the data which we have used to take out these two values. Okay, further, right, mn in terms of p and q. Mn means starting from this part, mn, right? Mn in terms of p and q. So mn is equals to, this part is equals to ma plus an, right? Mn, basically this is the tail, so starting from this, ma plus an. So what is ma? Am is equals to q plus q2q, so ma is equals to minus 2q. An is equals to p plus 2 upon 3p, right? Okay, summing this up, minus 2q is because I have no other component of q, right? So I'm not taking LCM of this, I will take LCM of this. So this will be 3p plus 2p, right? So this is equals to minus 2q plus 5p upon 3. So this is 5 upon 3p minus 2q, right? That's all about question number 10, part A. Okay, moving towards the uh, second part, right? Part B. Okay, so the straight line NM cuts BC at X. So NM, this straight line is cutting at point X, right? Here. Okay, X is a midpoint of MN. It's a midpoint of MN. It means that X is dividing NM into two parts, equal parts, right? So this information is basically telling us that we should first calculate MX, right? So since we found out that MN was equal to minus 2q plus 5 upon 3p, right? Okay, so mx will be half of this, so it means that mx will be half of this whole part. So solving this, minus 1 upon 2 into minus 2q will give me minus 1 upon 2 into 1 upon 2 is minus q, right? Plus 5 upon 6p, right? Now the question was bx is equals to kp, right? And the value of k. First we have to calculate bx. So for bx we have bx is equals to bm plus mx, right? This is the calculation of bx. So bx is equals to bm. So bm is equals to q and mx is equals to minus q plus 5 upon 6p, right? So q minus q cancels, 5 upon 6p. So kp means, this is if we compare this with kp, so k is equals to 5 upon 6, right? That's all about question number 10. Okay, let's move further for question number 11, right? Question number 11, we can see again a parallelogram. We have a parallelogram A, B, C, D, and we have two vectors S, vector basically AB, S and ADT. Find in terms of S and T an expression in simplest form for BD. So we first have to calculate BD. So BD is very simple. We can see that BD is equals to BA plus AD, right? BA is in the opposite direction of AB, so it means that AB is equals to of BA. So BA is equals to minus S, right? Minus S, and AD is equals to T. So BD is equals to minus S plus T. Okay, let's to the second part, Cn. Okay, second part is Cn. So Cn is starting from C till N, right? This now this vector is to be calculated. So for Cn we need Cn is equals to Cd plus Dn, right? Cd is still known, but Dn is unknown to us, right? Right now we calculated Bd, right, and Dn is part of it. So Dn, since we calculated Bd, so dB will be equal to since Bd is minus S plus T, so dB is equals to S minus T, right? Why I'm doing this? Because I am calculating dn, right? And dn is in the direction of dB, so that's why I first stated that what dB is. So dn is equals to 1 upon 1 is the nd part, right? Which dn is the same in for ratio, and total is 5. 4 plus 1 5 s minus t. So that is dn part, right? Okay. We have calculated dn. We have calculated, we know CD, right? So Cn is equals to CD plus Dn. CD is in the opposite direction of DC, and DC is equals to S as of AB parallelogram. So minus S plus Dn, we just calculated 1 upon 5 S minus T, right? So taking LCM, 5 minus 5s plus s minus t. This is minus 4s minus t upon 5. So this is equals to minus 4 upon 5 s minus 1 upon 5 t. Clear? Okay. Moving to question number 12. Question number 12. Triangle again, right? You know, we have you done almost 11 questions, and you must have noticed that using the properties of parallelogram, using the ratio, and using all these simple things, we are solving the vector questions. That's all. Okay, in this question we have O is the origin, we have position vector of P, that is equal to 2OA. Okay, and OQ is equal to 3OB, PM is equal to MQ. Quite a simple question. OA is equals to OP is equals to P, right? And OQ is equals to Q. Since OP is equals to 2OA, right? It means that OP is equals to 2OA and OP is equals to P, right? So OP upon OA is equals to 2 upon 1, right? OP is equals to P, OA came down, 2 is here, 1 goes there. Okay, now I want to calculate OA, right? So OA is equals to 1 will go over there, 2 will come in the middle, in the denominator, 1 upon 2 P. Clear? So OA is equals to 1 upon 2P, of course, right? Okay, now we are left with, we have to calculate BA, right? We have to calculate BA. So BA. So this is starting from here, BA. So for BA, I need OB, I need BO, and I need OA. OA is calculated just now. I need BO, or first OB. So here what I have is this whole OQ is equals to Q, and the ratio of this is OQ is equals to 3OB, right? Given the question, 3OB. So OQ is equals to Q upon OB is equals to 3 upon 1. So OB is equals to 1 upon 3Q, right? So OB is equals to 1 upon 3Q, right? Now for BA, what I needed is BA is equals to BO plus OA, right? So BO is equals to minus 1 upon 3Q, and OA is equals to 1 upon 2B, right? That's the answer. Clear? Okay, now position vector of M, part B. Starting from this, if I first erase this one so that we can understand this better. Starting from O until the M part, right? This is OM, which I need to calculate. So for OM, I need OP and PM. OM is equals to OP starting point plus PM. Now since OP I know that is equals to P, I just need to calculate PM, right? So for that I will be first erasing this up, right? Okay, so PQ, for to calculate PM I need to have PQ, right? So PQ is equals to OQ, the second vector, minus the first vector, and OQ is equals to Q and OP is equals to P. So PQ is equals to Q minus P. And since the statement is PM is equals to MQ, it means M is the midpoint of this whole PQ, right? So PM will be equal to the half of Q minus P, that is 1 upon 2 Q minus P. Clear? Putting the values, OP is equals to P plus PM is equals to Q minus P upon 2. Taking LCM over here, so this will be 2P plus Q minus P. 2P minus P is P plus Q upon 2. 2P minus P is P plus Q upon 2. That is what? OM. Clear? Okay, let's move further. Question number 13. It's quite simple. We are given the vector M, 3M. We have to calculate. So multiplying by 3 by both the components, 3 5 is 15, 3 7 is 21. Question completed. Part 2, we are given the vector. We want to calculate its magnitude. So magnitude formula is x square, that is 10 square, plus minus 24 square, right? So this is about 10 square is 100, and 24 square is 576, because it's minus sign, but since it's square, so minus sign vanishes. Using the square root, this 676, and the answer of this is 26 using calculator. Clear? That is 26. Okay, moving further, question number 14, right? 13b, sorry, 13b. Okay, in question number 13b, what we have is, we have a parallelogram. We are given two position vectors of A and C, and we have E is the point such that AE ratio EB is equals to 3 ratio 1. Find OE. Okay, so we have to find out the position vector of E, basically that is OE, right? The question which is asked is like this. He can ask us like this, find OE. He can also say that the position vector of E, both means the same, right? We want to calculate OE. So a very easy way is OA plus AE, right? So OE is equals to OA plus AE. OA is P, very simple. For AE, we need to first know that what AB is, and AB is equals to Q as per the parallelogram property, right? Okay, what AE is, AE is a part of AB, and the ratio of that is A is equal to 3, total is 4, 3 upon 4 Q, right? Putting the values in this, OE is equals to OA is equals to P, and A is equals to 3 upon 4 Q. So that's the answer, P plus 3 upon 4 Q. Quite simple. Okay, moving forward. Question number 14. In question number 14, we have parallelogram OPQR, OPQR, OPQR. Okay. Again, these are parallel lines, right? And equal lines, of course. So using that property, we can say that ST and PQ are same as OR, A, and A. Similarly, OP is B, so SO is also B. This is B. This is B, right? Okay, STV. This is the line STV is a straight line showing the ratio ST ratio TV is equal to 2 ratio 1. Okay, let's see what we need to first find out. The finding part is position vector of T. So it means that O till T, right? O till this we need to find out. So OT is equals to two parts. So just I'm choosing this part OR plus RT. So OR is equals to, so OR is equal to A, and RT is basically the reverse direction of TR. So TR is B, so RT will be equal to minus B. So the position vector of T is, that is OT, is equals to A minus B. Second is to find out RV. So RV is starting from R ending at V, right? There's RV, right? So RV is equals to, we have RT plus TV, right? So RT here, if I first erase this up because I need to use this part, RT is minus B, and TV I don't know, so first calculate TV, right? So TV is basically, we have ratio of ST ratio TV, so using this information, ST upon TV is equals to 2 upon 1, and ST is equals to A. TV I need to find out, right? Okay, so this implies that TV is equals to, this moves there, 2 moves there, 1 upon 2A, right? So TV is equals to 1 upon 2A. Clear? So putting the values, RT is equals to B and TB is equals to 1 upon 2A. We have RV B plus 1 upon 2A. Clear? Okay, moving further. What we first read the third part, part B. Show that PT is parallel to RV. PT PT is parallel to RV. PT. First, we will calculate PT, right? So first calculating PT over here. PT is equals to PQ plus QT. PQ plus QT, right? And PQ is equals to A, and QT is basically in the reverse direction of OP, right? So, and QR is equals to B, QR is equals to minus B, RT is equals to minus B, so minus 2B, QT is equals to minus 2B. So PT is equals to A minus 2B, and RV, what we calculated over here was B plus 1 upon 2A. Okay, wait, so RV is equals to B plus 1 upon 2A, right? That was so here was RT we used, so this is minus B. RT is in the reverse direction. Similarly, RV is in the reverse direction. This is minus B. There's a mistake. Okay, now I've corrected it over here. Okay, now what the question is saying, show that PT is parallel to RV. PT is parallel to RV. For the parallel condition, we should know that one vector should be a scalar multiple of the other, right? What does this mean? Let's see over here. I'm erasing this off. Okay, so we can see that RV is smaller than PT, right? So PT must be some multiple of RV. For example, I can say K, right? Now let's see. If you notice over here, this is if I write PT like this, minus 2B plus A, and RV is minus B plus 1 upon 2A. So since PT is bigger than this, if I see RV, if I multiply RV by 2, so RV by 2 will give me minus 2B plus 2 multiplied 1 upon 2 is A, minus 2B plus A. So you see, so basically PT is equals to 2RV. It is a scalar multiple of RV, so that shows that PT is parallel to RV. Is it clear? Okay, going further, the last 15th question. I hope everything is clear to everyone. Question number 15 is Ahmed increases 40 by 300%. From this, let's put a ring around the correct calculation. So increasing 40 by 300% means 40 multiplied by 300 upon 100, right? So 0 0 cancels. We get 40 multiplied by 3, right? Which is this part is the correct calculation. In part A. In part B, Ahmed finds the magnitude of the vector 2 minus 3. We all know that magnitude is x component square plus y component square. So that is this part. Yes, this part. Because this is in bracket, this is not in bracket, so this is correct, incorrect. There's no root, incorrect. It doesn't contain plus sign, incorrect, brackets aren't there, no root, so this is the correct answer. So that was all about vectors. In first 15 questions are done. I hope everybody finds it and it will be beneficial for every one of you. So I would again request to all the viewers to promote these videos, and I'll pray inshallah that these videos are beneficial for all of the viewers. Jazakallahu khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.